Hi friends, welcome to the Unit 3 Day 3 notes. This one talks about zeros of polynomial functions. This really combines a lot of what section 3.2 was about. If for some reason you didn't have a good solid understanding of Unit 3 Day 2, you want to go back and revisit that, reach out to your instructor for help. This really builds off of that. The factor theorem is an idea where if I can take a factor of a polynomial, so x minus k, then if I plug that k value back in to that polynomial, I get 0. This IFF stands for if and only if. This is a biconditional. Biconditionals in geometry, remember we learned that they have to go both directions. They're true both ways. So if I have a value that I plug in for k to a polynomial and I get 0, then that means that x minus k is also a factor. And we can use this idea to essentially take a higher degree or larger degree polynomial, factor it, and then find the zeros using that. That information is also going to help us in developing graphs and developing kind of an understanding of what's happening with that polynomial. So let's go ahead and work through a couple of these together where we have, in this example, I'm going to say one of the factors, one of the polynomials is given. We need to find it in fact, we need to find this polynomial in factored form. If 5 is a 0, I'm going to use synthetic substitution, knowing that I'm going to get a remainder of 0. To find what the resulting polynomial is when I'm dividing. In this case, remember, if 5 is a 0, that means x minus 5 is one of the factors already of this polynomial. So we already have one of them. My coefficients are going to be 6, x cubed, negative 37 for x squared, 32 for x, and then 15. It doesn't look like that this does, in fact, come out to be a remainder of 0, but it does, I promise. 6 times 5 is 30. 30 and negative 37 is negative 7. This gives me a negative 35, negative 3, and negative 15. So then my resulting polynomial that I have here is 6x squared minus 7x minus 3. So now looking at this, this is actually factorable using techniques that we've discussed earlier. If I use the factors of 6, 1 and 6, 2 and 3, that's really small. I'm going to make that a little bit bigger. 1 and 6, 2 and 3. There we go. And then this one's 1 and 3. So I know that that 1 and 3 combination has to be for my last factors. I know it's because this is a minus, I know I'm going to have 1 plus and 1 minus. X minus. All right, so just looking at this, I'm trying to get a negative 7. To get a negative 7, I'm going to do, I know 3 and 1. I think I want a larger value for my negatives. I'm going to put that 3 there, that 1 there. 2 and 3 looks more promising. So I'm going to do 3 here and 2 here. That gives me negative 3 times 3x is 9x, and then plus 2x. So that actually is the factored form of that. There's my work. So the factor, to write the polynomial in factored form, so that means f of x is equal to, don't forget the x minus 5. A lot of students will forget that. Remember, we got that x minus 5 because 5 was a 0. Then the other one is 3x plus 1, 2x minus 3. That means the zeros for this one, if I set each of these equal to 0 and then solve, that would give me my zeros for it as well. For number 2, it says factor it. It doesn't actually give me any of the zeros. In this case, that tells me that it's already in a form that I can factor with information that we've used previously in the course. So for this case, x cubed minus 4x squared minus 16x plus 64. This looks like factor by grouping. And I factor out an x squared from this, I'm left with x minus 4. If I factor out a negative 16, then I'm left with x minus 4. So if I group these together, then let's see, I've got x minus 4 times x squared minus 16. But x squared minus 16 is a difference of squares. I'm going to have x plus 4 and x minus 4. Now, I have x minus 4 twice. We don't write it twice. We'll take it and we'll say instead that it's equal to x minus 4 quantity squared and then x plus 4. I wanted you to name the zeros on this. So the zeros, again, if I set each part to 0, set it equal to 0, and then solve. So if I set x minus 4 equal to 0, I get my x equals 0. So I'm going to have, for this one, I have a positive 4, and then for this one, I have a negative 4. Again, I set them equal to 0 and then solve. So x minus 4 equals 0, add 4, add 4, x equals 4, and x plus 4 equals 0, minus 4, x equals negative 4. So with this example, those are our zeros, but we've talked about this previously, where they need to have the terms, they need to have a number of zeros matching the degree of polynomial. And so that's when we have the situation that we have here where we talk about multiplicity. So now I'm introducing this concept of multiplicity. With multiplicity, I want you to list out the multiplicity of each of the zeros so that when we get finished, we should account for the highest degree power of the polynomial. This one, x squared and x, this would be a 5th degree polynomial. So when we get done, we should have essentially the multiplicities of everything and all our zeros should add up to 5. Let's verify. So with this one, I can actually factor x squared minus 9x plus 18. Using the methods that we talked about previously, this one's actually very nicely factorable. X squared minus 36 is also a difference of squares. So here, I have 1 and 1 for the 1x squared. And then the 18, I have a little bit more. I have 1 and 18, 2 and 9, and then 3 and 6. 3 and 6 is going to be what I want to use because both of these are going to have to, this is a positive, so both of them will have to be negative. So x minus 3 and then x minus 6. I know that will sum to be that 9. That x squared minus 36 is a difference of squares, so that gives me an x plus 6 and an x minus 6. Then I also have an x minus 3. So again, I'm going to group these together. So I have, let's go with x plus 6 first. And then I have x minus 3 quantity squared. So I'll take care of that one, and then I'm left with an x minus 6 quantity squared. So if I think about the degrees of all of these, the degree of this one is 1, 2, and 2. That gives me my 5 that we were talking about earlier. My zeros, if I set these equal to 0 and then solve, I actually get the values. I put them in order, this particular order on purpose. I get negative 6 for this one, and which is my smallest, my lowest value. And then here is 3, but I'm going to have a multiplicity. And I abbreviate multiplicity, MULT, multiplicity of 2, and then 6 with a multiplicity of 2. So this is the multiplicity of the zeros. We use this when we graph, because having an even multiplicity will tell me what happens, and having an odd multiplicity also tells me what happens. Now notice negative 6 appears once, that's an odd multiplicity. We'll talk about this more when we get into the actual graphing component of this, but just know that it serves a purpose besides just checking a box here with making sure that these zeros add up to be the highest degree of power. Thank you for joining me in this video. In the next video, we're going to be talking about the rational zeros theorem. Have a wonderful day.